So the next one will be a parabola. So I need to generate my basic pattern for that. Basic pattern for parabolas. Just use -3, -2, -1, 0, 1, 2, and 3. And then -3 squared is 9, -2 squared is 4, 1, 0, 1, 4, 9. So the function that I'm going to sketch with the transformation is g as a function of x equals 1/3 of x squared. Now, do you notice that there is a multiplication factor in this one inside of the square? So if you have a multiplication factor inside the function, it is a k value. And in this particular case, I have a k value that is greater than 0 but less than 1. So the way to interpret that is that your x values, before I get to square them, I have to cut them in 3. So I've already limited their effectiveness, which means I have to go further out the axis in order to get the same punch from my function. So this one here, this -3, if I pop a -3 in here, the first thing I have to do is divide it by 3, and I get -1. So this value, right, my 1 up on the axis, isn't going to happen until this x value. So I'm taking those values, those dots, and I'm pushing them out from the axis. So if I have a k value that looks like that, this will be a horizontal stretch. And for a k value of 1/3, it means that they will be 3 times farther from the axis. So I'm going to grab my grid then. Put on my untranslated axis. Now my basic pattern for a parabola is 0, 1 and 1, 2 and 4, 3 and 9, 4, 5, 6, 7, 8, 9. This horizontal stretch is saying that I have to take these dots, and however far they are from the y-axis, I have to make them thrice that, because it's 1/3. So this dot is right on the y-axis. It doesn't go anywhere. These ones are both 1 square away. If you're 1 square away and I triple it, then you should be 3 squares away. So 1, 2, 3. 1, 2, 3. These two dots are 2 squares away from the y-axis, so triple that would give me 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. These dots are 3 away. Triple 3, you get 9. So 3, 4, 5, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. So I end up with this parabola that's been dilated outwards, right? Pushed away from the y-axis. So if I sketch those in there, it looks like this. So applying a transformation to a square root function, we're going to need to have my basic pattern. And for square root functions, we didn't bother using any x values except the ones that had nice square roots, which means no negatives are allowed. I start at 0. 1 is a perfect square, so is 4, 9, 16, 25, etc. Square root of 0 is 0. Square root of 1 is 1, square root of 4 is 2, 3, 4, 5. So the function that I'm going to sketch then is the square root of 3x negative 3x. Now, you notice that that is a multiplication factor, and that multiplication factor is inside of the function. That makes it a k value. And a negative in either an a value or a k value ends up being a reflection. And so since it's a k type transformation, this will be a horizontal reflection. And because this k value is a number bigger than 1, I'm going to end up with my x values being more effective than they normally would be. That's going to pull the function closer to the y-axis. So it's going to end up being a horizontal compression. Reflection and compression. So if I get my axis out here, you're probably getting tired of hearing me say that. My untransformed function used to be at 0, 0, 1 and 1, 4 and 2, 9, 4, 5, 6, 7, 8, 9 and 3, 16 and 4, but I've lost those dots. So, here we go. This dot here is 1, 2, 3, 4, 5, 6, 7, 8, 9 squares away from the y-axis. Two things happen because of this k value. First, it gets reflected so that it's 1, 2, 3, 4, 5, 6, 7, 8, 9 squares on the left instead of the right. So I've reflected it. Now that 3 says I should get there 3 times as fast, which means it should take a third as long. A third of 9 is only 3 squares, so I'm there. This dot was reflected and then crushed. This one, reflected, would be 4 squares over. A third of 4 is 1.3. That's here. This dot was reflected. A third of 1 is a third. And this guy gets to stay right where he is. Now, I maybe have some room for more of these dots. There was one at 16 over here. So if I reflect it, it's 16 on that side, and then 16, a third of 16 is only 5.33. So I'd be at 1, 2, 3, 4, 5, and a third. This one used to be 25 squares that way, so reflect it, it's 25 squares this way. A third of 25 is 8.3. So 1, 2, 3, 4, 5, 6, 7, 8.3. And I get this lovely square root function happening on this side of the axis. Now notice, negative x's are allowed in this one. And that's weird. You're not supposed to be able to take a square root of a negative. But look at what happens in this function. So you pick negative 4. It's right there. Negative 4 goes in here. Negative 4 times negative 3 is positive 12. And that I can square root. So the positive 12 square root of that is somewhere between 3 and 4. So notice that my function is somewhere between 3 and 4.
You can sketch a cosine that has both an A-type transformation, which affects it this way, and a K-type transformation, which affects it this way. So first things first, the cosine pattern has to fit inside of a rectangle that is 360 degrees long. that rectangle has a midline in it. And the cosine pattern is start high, end high, trough dead center, and then zero out halfway between those, like so. More or less. So when I set my grid up, keeping in mind that this thing has to be 360 degrees long, actually moving up by 1, 2, 3, 4 on my x-axis is going to take forever. I'm never going to get the whole pattern. So I'm going to have to choose a scale, and I like to go up by 30 degrees. I think it gives you a good picture of your function. So I'm going to put in my x-axis here. That's the y-axis, actually. It'll be a long day. Goes my x-axis. That's just terrible. There we go. So this isn't 1, 2, 3. We're going up 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. And going the other way, 30, 60, negative 90, 180, negative 270. And if you've already changed the x-axis to allow this thing to fit on there, then you might as well change the y-axis to make the curve nice. So I found that if you go up by 0.5, you get a curve that's tall enough you can actually see how the thing moves around. So that would be 0.5. That makes this 1. This would be 2. Skip 1, 3. Skip 1, 4. Skip 5. And negative 1. Negative 2, 3, negative 4, negative 5. Okay, so once my grid is established, I would look for translations, which I don't have any, so I don't have to shift this thing around. I just need to put on this box, right, the 360 degree long rectangle. So starting from here, 360 degrees is there, and drawn stop line. Hope that's straight up and down. And normally, a cosine goes up 1 and down 1 from its basic pattern, or from its midline. But this basic pattern has been modified by this A-type transformation here. So what's that going to do to my cosine pattern? Well, first, this is sort of the translated version, or transformed version. That rectangle won't be 1 up and 1 down anymore. It will be 2 up and 2 down, because its height has been doubled. And this negative here is going to flip the function this way. So instead of starting high and ending high, it starts low and ends low. Peaks in the center, zeros out there. So this is the pattern I need to draw in each of these rectangles. So I'm going to draw in some scaffolding then. My peaks aren't going to land on 1 this time. They're going to land on 2. I'm going to dash a line in like that. My troughs aren't going to land on negative 1 anymore because of this transformation factor. They're going to land on negative 2. You can start to see that it's been blown up this way. And to handle this K-type here, that's just telling me I need 3 full cycles in 360 degrees, as the axes have been accelerated. So you get more function in the same amount of space. So used to be 1 full wave fit in here. Now I need to fit 3 full waves. So I'm just going to have to chop this rectangle up into 3 equally sized pieces. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can I skip a grid line? I think I did. 360 got a bit far on me. 2. There we go. 12 squares, and I need to fit 3 full cycles in there. So if you chop 12 up into 3 equally sized parts, that's 4 squares each. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Perfect. Can keep going that way because these functions go on forever. 1, 2, 3, 4. 1, 2, 3, 4. So I have expanded the rectangle vertically because of this A-type transformation. I have adjusted the size of the rectangle horizontally because of the K-type. I just have to map this reflected cosine into each of those boxes. So pick a box. I'm going to pick this one. Looks like it starts low, ends low, start low, end low. Peak exactly halfway, and then you zero halfway between those. So I've got this crazy looking thing here. Something like that. So one's not enough. I have to map that pattern into every rectangle. So start low, end low, peak halfway, zero halfway. Start low, end low, peak halfway, zero out. Start low, end low, peak in the middle, zero out. Start low, end low, peak in the middle, zero out. And I've got enough dots to sketch in this curve. Etc. So the trick to a translated cosine or sine function too is think about the rectangle that the basic function would fit in, and then you're going to make it taller based on your a value, and you're going to have to fit more boxes into the normal rectangle based on this. So if this number was 6, I would have to fit 6 rectangles in this box. If this number was 12, I would have to fit 12 rectangles into this box. It's always trying to shove it into 360 degrees. So I think that's it. You just need to be able to spot whether it's been reflected like this or reflected like this. Stretch your rectangle with your scaffolding so that you know where to aim for, and draw on your dot patterns, low, low, high, etc., and off you go.
For the last example, I'm going to use base 2 exponential as my basic function. I'm going to generate the pattern there. We have typically used x values of -2, -1, 0, 1, 2, 3, and maybe 4. Those are your x's. 2 to the exponent -2 is 1 over 4. 2 to the exponent -1 is 1 over 2. Anything to the exponent 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. And the function that I'm going to try and sketch for you is g of x equals -1/4 2 to the -1/3 x. Now, you notice that there's a multiplication factor out front, which is negative, and a multiplication factor inside the function, which is also negative. So I have both a and k values here. I have an a value of -1/4. Now that is a reflection. This is a vertical reflection. And when an a value is less than 1, it takes all of your values and drags them closer to the x-axis. So that's a compression. I have a k value of -1/3. And the negative means that it is a reflection, so I have a horizontal and a k value of that's less than 1 makes your x values less effective, which means you have to go further out in the x in order to get the same punch. So that takes all of your dots and blows them out, or dilates them away from the y-axis. So horizontal reflection and dilation. Or stretch, whichever word you prefer to use. So, for the last time in this video, summon the axis. Draw on my untranslated axis. And I'm going to map my basic pattern on there. -2 1/4, -1 1/2, 0 and 1, 1 and 2, 2 and 4, 3 and 4, 5, 6, 7, 8, and 4 and 16. So we're going to do these dots one at a time. Start with this one, just because it's up and in the way. So this dot, first off, I have to reflect it in A. That would put it here. Then I have to reflect it in K, which would put it here. Then I have to make it 1/4 of what its normal height was. It used to be 8, so now it's only 2. And it needs to be blown 3 times further away from the axis than it used to be. So it is currently 3, so now it will be at 9. So, reflected vertically, reflected horizontally, made 1/4 as tall and thrice as far. Check. Now we need to do this one. This is at 2 and 4. Reflect it, 1/4 of its normal height, and thrice as far. So instead of 2, I should be at 6. Check. This one, over 1 up 2. Reflect it, 1/4 of its normal height, and 3 times as far as it used to be. This one, reflect it, half its height, or 1/4 of its height, sorry, and 1/3 as far as it used to be. This one, reflect it, half, 1/4 of its normal height, and 3 times as far as it used to be. I keep saying half, I have halves on the brain, sorry. Do you notice I've got this feature happening here? My horizontal asymptote, which used to be on the left side above the axis, is now on the right side and below the axis because it got flipped twice. So if I sketch this in, my horizontal asymptote is over here. You get a function that looks like that. An exponential that is not only upside down, but also backwards.